Hi, now we will learn matrix in which the topic we are going to study is eigenvalues and eigenvectors. So this is a common, one of the most common question asked in GATE from linear algebra mathematics. Before we go into the matrix on eigenvalues and eigenvectors, I would like to explain what is a vector in our linear algebra. Vector is an ordered set of numbers called its components. So the set of numbers, the order set of numbers are called its components, called vectors components. And there are two examples of vectors. One is a row vector and another is a column vector. So a row vector is numbers, ordered numbers arranged in a row. Sort of an array, you can understand it as an array, and it is like 1 2 3. There could be any numbers, k numbers, and this is a row matrix of 1 cross k dimension. So this is a row vector, whereas a column vector, numbers arranged in a column 1 2 3 and k. So the matrix formed as k cross 1. This is a column vector. So vectors are nothing but set of ordered numbers, and these numbers are called components. So now we'll study eigenvalues and eigenvectors. Let Aij, which has values ai of the form Aij. I is the row and j is the column. Let A be a square matrix of order n. Order n means there's a matrix like this here, and it has values, some value, n values in the rows, n values in the columns, and the order is n cross n. This is a square matrix of order n, and I be the unit matrix of order, of the same order. So unit matrix is nothing but the identity matrix. Identity matrix is something, since it's of the same order, so same square matrix n cross n, but its value will be on the principal diagonal, all values will be 1 and all other values will be 0. Only on the principal diagonal will be value 1. So for example, 1, this is a unit matrix of order 2, okay, or 2 cross 2 unit matrix, identity matrix. Then in that case, let lambda be any indeterminate. So lambda, for now let's assume lambda is any scalar quantity. So lambda be any indeterminate. Then the matrix formed from A minus lambda I. So lambda multiplied by the identity matrix. So the matrix would be something like lambda 0, 0 lambda, any value of lambda. If we are taking the 2 cross 2 matrix like this, this will be equal to lambda I. Okay. Then A minus lambda I is called the characteristic matrix of A. And the determinant so formed, so determinant of this matrix A minus lambda I has various names. For example, it is the determinant of the matrix. It is also called a polynomial of degree n in lambda, and this is called characteristic polynomial of A. Okay, then the equation A minus lambda I determinant equal to 0 is called the characteristic equation of A. Okay, and when we solve this equation, the first equation, we get values of lambda, and those roots of this equation are called characteristic roots, also called as latent roots or the eigenvalues of A. So the values formed lambda 1, lambda 2 and so on are called eigenvalues of matrix A. If we say that the equation is of the form A minus lambda I into X, so this is the matrix A minus lambda I into X, X be any vector, then it could be a row vector or a column vector depending upon the matrix. We'll solve an example and I'll explain. So when we form this kind of an equation and we solve this equation, we get values of x. Now that we know the values of lambda, so we'll get some values of lambda from this equation. We'll put one value lambda 1 say in this equation, say lambda 1. Then based on that we'll get an x vector x1 say. This x vector is nothing but it's called the eigenvector. Solve an example and we'll understand this better.